Okay, so non-conscious memory. Does anybody doubt that it exists? Okay, so we're pretty sure it exists. Memory that we're not consciously aware of, but which somehow in our system seems to reside and operate and indeed drive changes in our behavior, in our performance on tasks. Okay, so it begs a really difficult question. How do you study the unconscious mind in conscious people? It's tricky, right? What I want to share with you is some strategies that we use for actually trying to accomplish that. Okay? So, what I'll do is just describe our paradigm and then describe how we adapt that paradigm in order to gain leverage on that particular measure of non-conscious memory, or what I'll call more simply implicit memory. So there's memory that we can explicitly say, I remember something about, and then there's memory that we can have which is implicit, which is to say that we can demonstrate that we remember something even though we can't explicitly say that we remember it. Right? Sort of, you guys have all taken intro to neuroscience. You know about Korsakoff patients or patient HM, right? Who is able to exhibit memory even though they told you, I can't remember anything. Okay, so we'll talk about how we can use the actual procedure that we use in our class here to tap into that. So remember that in our experiment, people had basically a retrieval test, okay, and during that time period, they saw a word on the screen. Let's say the word was, I don't know, airplane, okay? Okay, so they see a word on the screen. What else is on the screen? Confidence ratings for an old new memory judgment. So they're asked, do you remember this item from study phase? Is it an old item? Or is this a new item that wasn't in the experiment before? So they're asked, is this old? Or is it new? And as you very accurately said, they were asked, how confident are you about that memory? Okay. Can you see okay? Is that better? Okay. So, we had a confidence rating. Let's say 1, 2, 3, 4, 5, such that you had an old item that could be highly confidently judged, as remembered, or said in a different way, you can have an item reported explicitly with their conscious awareness saying, yes, I am very, very sure I remember having seen this before. Or they can say, yeah, I've seen it before, I'm just not quite so sure. You can say, oh yeah, I definitely think this is a new item, right? Which means that if it's an old item, I've forgotten it because I don't remember seeing that before. I'm very sure about it. You can have less sure, 2 responses. Okay? So what we can do when we analyze this data is we can start to keep track of it. We can make a little grid. Okay? And the way that we can do that, right, is first we can categorize that during our memory task we have 2 different situations of what can pop up on this screen, right? What we'll call status of the item. The status is that it could really be an old piece of information that they saw before. So we'll call that our status here. It can be an old item. What's the other sort of a status it can be? No. So remember we talked about this a week or 2 ago about signal detection theory? We had that nice little grid, right? And we talked about false alarms, hits, misses, correct rejections, right? So you can have an old item that's a hit, that's accurately called old. You can have an old item, right, which is a miss, that is inaccurately called new. And by the same token, you can have a new item that's correctly rejected and identified as new, or you can have a new item to which there's a false alarm, and they accidentally have a false memory and say, oh yeah, I saw that before. You're like, really? Because it wasn't in the experiment, right? So we can identify that we can have hits, miss, false alarms, and correct rejections, okay? So we have these different situations. Now at first pass, what we typically do to measure explicit memory in EEG is we compare hits to correct rejections. Explicit recognition memory, right? Hits to correct rejections. So you do that versus correct rejections equals explicit memory. Make sense? And of course, we talked about this a class or two beforehand. One way to take a look at the implicit memory is to compare activity for misses versus correct rejections. Okay, so you do misses versus correct rejections as a measure of implicit memory. Why is that the case? Why does that work?
In the misses, there may be the memory may be there, we just didn't access it. It didn't reach conscious awareness.
Indeed, it might not have reached conscious awareness, and it could be in there because it's actually an old item that they just forgot. But why is this? What's really important here isn't the single condition; it's the comparison. Why is misses versus correct rejections an important piece of leverage on non-conscious memory that you couldn't get in, say, misses versus false alarms? Yes! I love it. It holds the conscious aspect constant as a control. So when you have this miss versus correct rejection, okay, the subjects have told you the same thing in each case. Their conscious experience was the same, which was, yeah, I don't remember it. But it differs in reality. The reality of the situation is that the status of the information is actually different. Even though they might tell you, yeah, I don't remember it, in both situations, we know that in reality, the situations were actually quite different. That's really important, isn't it? Because it says that if we look at the EEG trace, okay, let's say that's one particular condition. Let's say this is of a miss. The hypothesis is that if we make a trace of correct rejections, it should go exactly the same. If the biophysiology or the neurophysiology is only mapping our conscious subjective reports. Right? But what if the correct rejections actually happen to differ? What does that tell you?
There's something else going on.
There's something else going on, and beyond that, what does it tell you?
There's a non-conscious process to it.
Yeah, it's telling you that we have a biological signal of memory that the mind has forgotten. We're telling us that the brain is remembering, even though our conscious mind has told us it has forgotten. You guys get that important leverage and insight which is offered? Okay. So, we talked about this a class or two about, right? This is one way of studying implicit memory. But we can do it better. Okay? So the reason I can say we can do it better is because there's some slight limitations to this approach. It's been useful, and people have published with it really useful things that should. So typically, when we do this explicit memory, let's say you might compare hits to correct rejections, and let's say from 400 to 600 milliseconds, you might look at our topography, right? Here's your ear, here's your nose. And if you do, you might see this mid-frontal effect. Okay? So that's your explicit memory. Now your implicit memory, if you subtract these two conditions, we get our difference wave. You guys are all experts of this, right? If we look at that during the same time period, okay, 400 to 600, what we can see is that there's actually a posterior effect for that as opposed to a frontal effect for that. So we can see is a topographic dissociation, which means that we can see that not only is the brain remembering what the mind has forgotten here in our ERP trace, but if we look at the difference wave of the actual memory effect related to that difference, we can see that it actually statistically and reliably is different from the spatial distribution, the neurophysiological signal associated with explicit memory, which is on a totally different part of the scalp. That type of analysis is called a topographic analysis. If anybody's interested in doing that for their projects, talk to me later. I can show you some ways to do that. It's a little bit more complicated, but we can get to that. But the point is, we can see that these are different signals, and it's kind of like being a defense attorney in court. Okay, your client has been wrongfully accused of robbing a bank. How do you get him off the charges? Well, what you need to do is you need to create an airtight alibi to show that who he is and who the actual culprits are very, very different people. What's one way of doing that? You get an airtight alibi that says they are in different places during the same time. During the time of the robbery, I have an airtight alibi saying that this guy was in a totally different state of the country. Therefore, they cannot be the same thing. Therefore, these two signals, explicit and implicit memory, have to be different. Different places, same time. You guys follow logic? Okay. So that's been a useful way that these comparisons have been used so far in the literature. There are some shortcomings, though, that can be improved upon. Okay? And for one thing, the idea is that if we have this type of a paradigm, all right, let's say we have 1, 2, 3, 4, 5, new, old. We have our different representative distributions here of, let's say, old items and new items. We're not going to get heavy into the cognitive psychology here. It's a whole other class. But we kind of have a criterion of where we set our decision of how we make memory choices based on if we think something is old or new. And the sort of simplified version of the conversation is that when we're looking at these hits, or excuse me, these misses and correct rejection trials, right? We're getting the 1s and the 2s. It's possible that there's just a little bit of old trials here, right, that are coming in to create our misses that have a little bit of familiarity in them, just a little bit. Remember, familiarity and recollection, we talked about their signals. And familiarity is basically an aspect of conscious memory. And people have argued in like the wonky cognitive psychology literature that this is a limitation of this comparison. Because it might be that this pattern that we see here representing these differences, it just might be that it includes a little bit of explicit memory of this familiarity bleeding in. Okay? So, how do we account for that? Well, we developed a procedure that I'm going to describe. Okay? And it takes very good use of this confidence spectrum. Alright, so I'll say a very general overview of it, and then we're going to dive into the details. Okay? The general overview is you equate for the strength of the memory confidence ratings between your old and new ERP conditions. So you want to make sure that each ERP of old and new trials represents the same amount of memory strength. Therefore, there's not a difference in how strong or weak the confidence trials are that are going in to create what might contain a little bit of these different memory strength ratings. All right? I'm going to get into making that a little bit more detailed and hopefully more understandable. Okay? In order to do that, I'm going to erase some of this stuff to clear out some of the clutter from our brains on the board so we can just focus on one or two things. Any questions so far? Okay. Now, let's see here. Now we'll get this too. Okay. And get that out of the way. Okay. So, here we are, sort of back where we started. And no questions yet? Okay. I have fun with a lot of this stuff because I spent like years diving into these details. So stop me if I get on too much of a roll. Okay. So the idea here, usually the way I start off this conversation is asking people the really tricky question that we started with, which is if our goal is to capture a physiological measure of non-conscious memory, and all we have to work with is this conscious memory task. How do you measure unconscious memory in a conscious memory task? Right. So I tell them that the answer is the same way which porcupines mate. Very carefully. Yeah, because the yeah. Think about how that. Yeah. Okay, so very carefully we will walk through this. That's exactly. It's actually really a quite elegant measure. All right. So we have different status trials, old and new. Let's separate that because we're going to make a chart. Okay. Okay, so we have our chart here. We have our status, old and new. Okay, I'll get rid of that. Because what we need to do, remember, we're going to select we want to equate for the memory strength while also holding confidence constant. Okay. So we have our confidence ratings. I'm going to make this into a chart. Okay. 1, 2, 3, 4, and 5. Okay. What we'll do is we'll sort of begin to use this chart to see what we can do here. Now, what we'll do is this is going to be the number of trials. Okay? So we're going to count how many times in our 300-word experiment. Remember, there's 200 of these, there's 100 of these. We're going to count how many times old items got rated with 1s or 2s or 3s or 4s or 5s by one particular person. Okie doke. And
the person's randomly selected.
Sorry?
The person's randomly selected.
Well, you do this for every person, but we'll just start with the first person. Okay? And do you have my paper open? Or do you have it here?
Yeah, actually.
Does it have the supplemental figure? Because you can actually tell me what the numbers were off the top of my head. Because it's got to add up to 100 or whatever. But the idea is we will. These are all going to. Let's say that we will add. These will all make essentially an ERP for old items, and these will make a different ERP for new items. Yeah? Let's see here. And let's... You see it? And so what we'll do is first we're going to just count up the number of times that they responded. And then we're going to randomly select the same number of trials in each of these vertical columns for that subject. And then we're going to average those across to create a new bin, or a new ERP versus an old ERP. Okay? You'll see this play out. You able to see that?
The one I have on the website doesn't actually have the supplementary figures.
Ah, the one I posted, no shit.
Is it table 1 or table 2?
It's in the supplementary figures. It's after the end of the paper.
You have to find it on another site. Which it is.
Sorry, e-learning?
I found it on Science Direct.
Oh yeah, it's well it's not direct. It's supplemental player one.
Let's go to. Let's go down. No. There should be a That's okay.
Let's say that we have, I can bring it up too, actually. I'll just go off of here. And so let's say that they normally say 28 times here. They're going to have, they say 31 of these responses, 19, 28, and 54. This is a pretty normal pattern of responding because they say a lot of memory. Okay, so these are basically old, these are basically new. Okay, and of course they're accurately reject a lot of the new trials too. So let's say it's 50, 27, 7, 5, 11, 7, 5, and only very few times do they make these false alarms, right? So these are going to be like false alarms. These would be correct rejections, okay? And then these would be essentially this, and these would be hits. Everybody on board? Okay, so this is normally how things would work to measure our explicit memory, and you would take the average of all these, this would give you an old ERP, and the average of all these, this would give you a new ERP, and that would basically give you our midfrontal effect for explicit memory, familiarity-based judgments, right? Old hat. We're bored by that. We've done that a lot in here. Yeah? What we want to do is very carefully, like Porcupine's mate, create a measure of non-conscious memory by virtue of this conscious memory reporting task. And here's what you do. For each of these columns, okay, you find out what is the least number between the two. So in this case, it's 28. In this column, it's 27. In this column, it's 7. In this column, the minimum number is 5. And in this column, the minimum number is 11. Everybody on board? Now what we're going to do is we are going to randomly select the same number of trials as evidence here out of these trials. Okay? So that what you end up doing is we go in our EEG file before we've averaged, after we've done artifact rejection, okay? And you randomly, and you reject a handful of trials so that you randomly select 28 out of these 50. And instead of having 31 trials here, you randomly select 27 of them. Instead of having 19 trials here, you randomly select 7 of those 19. Okay? Instead of having 28 trials in our hits, we randomly select only 5 out of the 28. And of course, instead of having 54 trials in our hits for high confidence, we're going to randomly select only 11 of those for this subject. Now, these numbers are going to be different for every subject because every subject has slightly different response distributions, right? Yes, sir.
Is there a way you have to do this manually? There's no other way around it?
Right now, the way that I do it is manually because I'm very conscientious to make sure that I do it correct, and I haven't programmed it yet to be done properly in EEG Lab for the trial selection. I have no doubt that there has to be a way to do it. I haven't sorted it out yet, but it works perfectly fine manually, so I'm very careful to make sure that it's done manually. And what you do at a technical level is I have a script that will output our list of your trial number, and then we have our event code in it, and this is all in Excel. So you have trial 1, 2, 3, and 62, 4, 5, 61, 5, 2, and etc. Right? There's an event coordinate. And so we get this output in Excel, and then what you do is I have a calculator sheet that will count up how many trials are in each of these bins, and then I have another little calculator underneath it that just does all the thinking for you. It already calculates it all. It's a nice little equation setup, and it will identify what the minimum trials are for each condition, and then you go through by hand, and we add another column here. Okay, and we basically you have a random number between a certain point, and so you have a random number here, here, and here, and you sort the data, basically sort by the random number, or excuse me, you actually sort it by our event code, so that all of these are organized together, and that makes it really easy to randomly select which of the trials you want to do within each condition, because you go through and each condition is set up together. And then you resort it again. So you sort by the event codes. 2, you randomly select trials. 3, what you end up doing is then you basically resort so that it's back in trial order. Okay, so that gives you an opportunity to basically, don't forget about the random thing here. We'll just say, do you want to accept or reject the trial? Okay, so you're either going to accept or reject. Now you're going to have your nice little list in Excel. It tells you for each trial number whether to accept it or reject it, right? And so then what you end up, the goal conceptually is then what you do is now you create an average of all these, and it becomes our old ERP. And you also create an average of all of these together, and this is our new one, new versus old. Okay, when we plot it on top of each other, okay, that might be the plot for our modified old trials, and this might be the plot for our modified new trials. What we can see is the same idea before. Anywhere where there's that difference between conditions is evidence of where the brain is showing it remembers something from the past, even where our mind has said, I don't. And we know that it cannot be attributable to differences in memory strength or low levels of familiarity or anything there, because we've absolutely held it constant. So the same every one of these confidence reports is the subject telling you how strong or weak their memory is. And we've absolutely held that constant. We've held it equivalent. So it cannot be used as an excuse to explain the data effect. And the only thing left that differs between this condition and this condition is the fact that one was experienced before and one was not. Do you appreciate the elegance? I didn't devise this, so it's not like I'm saying my measure is elegant. I added to it and I verified it, but I still think it's an elegant procedure. And so that's what we want to see. And then, of course, you subtract that and we create our topo map again. And what we ended up finding was a nice posterior effect again from 400 to 600 milliseconds when you do old minus new. Yeah? Which actually converges really nicely with the earlier measures. This is just a more robust way of measuring it without having it conflated with the possibility of memory strength or familiarity. Does that make sense? So, what you do then, once it's been resorted by trial order, right, we come back from Excel into EEG Lab again. We do what we did before for artifact rejection. Remember, we do what is it? Data plot channel scroll or something? Edit channel scroll, right? I think it's plot channel scroll. So we're basically EEG Lab, plot, channel data scroll. And what happens when we did that? What do we see? We saw a bunch of EEG, right? So we get our nice little window of EEG. Okay? There was our electrodes, right? So F1, P1, C1, T1, F2, F3, yada, yada, yada. And they're all going across. You guys remember all these good figures? Yeah? A lot of artifact rejection. Now we're not looking for artifacts because we've already cleaned them out. But we still want to reject the trials because, of course, that's the very nature of what our goal is. Okay? We're just going to reject the trials now, not because they're bad, but because we don't like them. We want them out. They're good trials, we just want them out. So, this is epic data. So it's already sliced. Remember this? All right? Let's say this says 62.45, 61.52, 63.44, 61.14, blah, blah, blah. And what you do is, because in Excel, we've identified whether we want to accept or reject each of our trial numbers, right? So this is basically 1, 2, 3, 4, 5, right? So over here we said we wanted to accept trial 1, right? So what do you do to it? Absolutely nothing. Trial 2, what do we say we want to do? Right? So we click on trial 2 to reject it, and it turns yellow, right? It is now rejected. You go through down your list, it should go down to about 280, depending on how many trials you had saved. and you do that same procedure by hand. There might be a way to do it if you code it. I don't know what that code is. You're welcome to try. I'll give massive extra credit if you can write a beautiful script to sort this out. I just haven't had the time to devote to that. And it works for me to do it by hand. It just takes some really careful time. And then you do that for every subject. And then you average and create a group average, yada, yada, yada. And you can see, do those ERPs differ? Maybe they don't. If they do, where in the scalp and when in time? Now, the nature of that study was such that we found, so I'll draw the same scalp map that I drew over there for those who can't see it. So from 400 to 600 milliseconds, if you contrasted that modified old minus new difference wave, what we found was it was associated with this pattern of activity in this posterior area of the head that was related to implicit memory. What else did we find? You know? So it turns out this wasn't the case in some people. Which people? Amnestic people. Well, why did they have amnesia? Oh, they're hippocampal patients. So it turns out we have the inverse problem, right? You can't say what something at the scalp is related to just by virtue of trying to mathematically work down. But if you can experimentally control which area of the brain is even present, which we can because we include people who don't have certain areas present, it turns out, okay, this was in normal subjects, okay? If you looked at the same thing, 400 to 600, you do that modified, old, and I put parentheses on it because I want to show that it's modified. It's not a real, authentic old-new contrast because we've gone in there heavy-handedly and manipulated which trials, right? Now it's random, it's a random selection, but at the same time, you know, it's not an explicit measure of real old versus new. It's of course a modified measure. So I put the little parentheses around it, and it turns out they did not exhibit this at all, but instead they exhibited something that kind of looked like that. Very, very different. And in fact, this implicit memory effect was completely abolished. So it seems that this is a hippocampal dependent memory effect for implicit memory. But it turned out that if you measured the same time period, 400 to 600, and now we did basically our FN 400 for explicit memory. All right, so this is implicit. And I'll say that, I'll remind you that these are our patients. Okay. And this is implicit. All right, this is explicit memory now. Our patients were perfectly fine in showing an FN 400. So remember we talked about patient HM a few moments ago? Famous amnesia patient? Patient HM was famous because he showed us an example of hippocampal damage resulting in loss of explicit memory that left implicit memory normal. He became famous. This famous study. He gave us everything in the textbooks, right? We just found the opposite. Pretty cool, right? Because we have patients who have hippocampal damage who are fine in at least one measure of explicit memory that patient HM told us should be amnestic. Or not so much. But patient HM also said that hippocampal damage does not affect implicit memory. And therefore that implicit memory does not depend upon the hippocampus. But that was based on behavioral measurements. Tower of Hanoi, mirror tracing task. We, or in this case, this is the first study ever to use EEG physiology to measure implicit memory and hippocampal damage. Turns out that when we looked, we found the opposite of what he exhibited, which is that they actually did have an impairment in implicit memory. Therefore, at least one form of implicit memory does seem to be dependent upon the hippocampus. Which means the textbooks saying otherwise are wrong, in my humble estimation. So, that's my little journey into implicit memory. Conceptually, technically, in terms of how to do it, and the procedure of the analysis of how to do it, and and how to interpret it, and sort of what it means, and yeah. What do you think? Yeah.
Patient HM thought it said you can't do the physiological bit. Can you do the behavioral test?
Yeah, that's a really good question. That's my next experiment that I'm trying to run right now, is exactly that. So she asked if you guys in here, can you run the behavioral test? Right? So I give talks about this and presentations at other universities and conferences and stuff. And I always ask people, like I just did, like, well, what do you think, or what's next? Because I know that's the next question. And everybody stays quiet. I'm like, guys, come on, this is the most obvious thing. It has to be done. We need to get behavioral measurements of this to correspond. And that's what we need to do next. So you remember when we talked about this study, in the procedure, we told them to not blink. We also said don't respond for a minute or a second and a half until the numbers pop up on the screen, right? So we can get a clear trial that doesn't have blinks that we have to reject. You guys remember that little detail? So what that means is when they gave their reaction time response, it was meaningless. So usually one behavioral measure of implicit memory is to study how fast people respond to items, because if they implicitly remember it, they'll probably respond a little faster. So it's a really nice behavioral measure, completely thrown out the window in this experiment. It's completely useless because we said, don't give us your real reaction. So what we want to do is I want to run the study again, this time add reaction time measures, and see if it corresponds to a behavioral thing. Nobody says it. I'm like, guys, come on, say it. It's so obvious. It's exactly what needs to be done. So, trying to get funding to do it. First, I want to do it in normal people, but I would like to take it back to patients. It's really tough to find patients with clean lesions who don't have contraindications of medications or drug use or other things that led to the amnestic disorders that can complicate your interpretations and add to messy data. So it's really hard to find these patients. The ones I tested in 2009, which is when the patients were actually tested, even though the paper was 15, they're essentially gone now. Yes, sir.
The way you found, I think I already asked this, the way you found those patients, they were in a VA hospital, right?
Yeah, VA hospital.
And what caused the lesion? Was it stroke or was it carbon monoxide?
So sometimes carbon monoxide can lead to these hypoxic deficits in the hippocampus. These patients were identified from causes of hypoxic episodes from heart attacks. So we had 3 patients. 2 of them had hypoxic events from heart attacks. Heart stopped beating, lost oxygen for a short period of time. The third of the group was hypoxic by virtue of a coma from a traumatic brain injury in a car accident. So left everything else intact. It was otherwise neurologically and neuropsychologically fine and intact, but the hippocampus was specifically damaged. So if you look in the paper that is on of this on e-learning, it shows a real nice picture of the MRI scan of the hippocampus damage, showing the rest of the medial temporal lobe totally fine and intact when we measure it quantifiably with volumetric measures. And yeah, it seems to be exhibiting this deficit that corresponds to that. So that's where it comes from. But carbon monoxide is a good way that a lot of people get other patients and stuff like that too. So yeah. So that's one procedure. Now, this is what we were talking about last class, if you remember. You've been interested in looking into some analyses on implicit memory. Of course, you started the first version with misses versus correct ejections, perfectly fine. But this is another way to get into that in a little bit more specificity. And what we talked about was that I've reported this in the ERPs, as kind of, I drew the pictures of there, but if you look at the papers, it's actually pretty close correspondence with the pictures. But that's the ERP domain. Nobody's ever looked, ever, in the history of planet Earth, or at least they've never reported having looked, into the oscillatory domain. Can we see similar effects in alpha, beta, gamma, theta? Theta in particular we know is very influential frequency, supporting memory. Nobody's ever looked. We have the data. Take a look, guys. But we got to do this procedure. And it takes time. This is a very manual procedure. This is a lot more work than any other analysis you would do in this class for Project 3. Hands down. Which is why I offered other options, if you guys want to do it. But for those of you guys who are interested in maybe doing this, I will, I told you this last week, but it's just as true now. I will get the files together, the scripts to output our sequence of files, the Excel file that has this calculator in it that automatically does a lot of the work, but it will require that manual work. And to be frank, it's probably the best way to do it is to work in a collaboration with people, because what you're going to need to do to show this effect is you need to do this by hand, manually, for our 3 patients. Completely meaningless if you don't have anything to compare it to. So you have to do the same thing for 6 other control subjects. Arguably meaningless unless you have a larger control group to compare it to, because that's a really low sample size that usually EEG is insufficient for capturing. So the reason that this stuff was publishable for me, because I did it for all of the subjects that you guys have access to, all 50 or 60 some odd, by hand, myself, from my apartment in Oak Cliff in the summer. Like, it's a long time. And it was just poking away at night. It was like a little hobby of an experiment. I was just kind of doing it. And but my suggestion is if you really want to do it right, you do all the subjects, and you get a collaboration with colleagues who you guys split up who does what subjects. Disperse the workload. But the first starting point, which is what we talked about last class, is to start with the 3 and move on to the 6. So you can do that on your own. That's perfectly reasonable to do 9 subjects in this analysis. But if you want to do it more broadly and really replicate this paper's finding, I also did it in that group of 25, which included subjects 3 through 27 in your analysis. So for anybody interested, get together as a group, or just talk to me or send me an email and let me know you're interested in that, and I will forward those corresponding files to do that analysis. But you can do other stuff. Any questions? Yes, sir.
So for the oscillatory analysis, how would the statistics work for that?
How do the statistics work? Well, you basically extract the MATLAB array of the numbers for the values of theta power in the different conditions, and it's just an array, or basically a spreadsheet of numbers. And if you need to consolidate them, you create little averages and stuff like that. You extract that per subject. You create your same type of spreadsheet, And instead of doing statistics on mean amplitudes, you do it on the respective power of the frequency band in the different conditions. Now, like I said, ERP Lab software that we're working with is in beta mode for that. It's really well tested for the ERP statistics. Still sorting this out. Explore around, and like if you can't get it to work, but you can still get really nice figures, it's perfectly fine for the projects in this class. I will say that you would not need to report the stats for it if you can't pull it out. If there's some sort of weird error or it's stuck in beta mode, and do the results in that as a descriptive analysis. And you can take the figures and you describe qualitatively what the patterns of the data look like, and you will be permitted to not have to describe them quantitatively if that becomes the case. Does that sound pretty fair? That way I want to encourage you guys to try those analyses and do that. But the best person to answer that question is next week with Dr. Dana Russell, who does this stuff all the time. And she'll tell you more details on how to pull the actual stats out. So I would read one of her papers beforehand, read the Cohen chapters about oscillatory analyses, and the Steve Luck chapters, and the McKee paper from 2004, so you have a really good foundation, and write all the questions out that you have about that kind of stuff, because she's going to be really, really good for addressing some of that stuff. Sound good? Any other questions? Wake up, Mom. There you go. You good? Okay. You want some more coffee? I got a whole gallon. You can chug it. Are you sure? Okay. Well, I'm going to get some more coffee, perhaps even or something. I don't know what time it is, but you guys, stay and hang out, do whatever you need to do. And like I said, talk to me if you want to know more about the analysis, or if you actually want me to send you the details of the files. It's going to take me a couple days to get those files together, because I need to make sure that they're foolproof to send out to the class. Like, I need to work out a couple details to make sure that they're consistent with our operating systems and stuff like that, just so I don't give you guys problems. But don't even really communicate with me, but just communicate with me about it, and we do. But in the rest of the period to do whatever your heart desires. Yes, sir.
You were mentioning that if we were interested, we could tell us about
Oh yeah, interesting. Yeah. I will. So what I can do is I can send you a spreadsheet that does that. What it does, conceptually. Can I refresh my call? Yeah. The topographic perception, you want to know if that top left frontal spatial topography is a different statistically right or the bottom right you're steering. The null hypothesis is that they don't. It's just that they look like they're in different places. Because remember, spatial resolution with EEG is 3-4. So we want to know, is this just horrible spatial location, just everything just moving out is actually one big thing effect? Or is there a way to actually look at it? So the first thing that we need to do is comparing topography to effects. So when we're talking about topography, remember what we're talking about is basically mountains and valleys. Like the hiking.
the topography map of mountains and valleys or undersea maps that it works for you. Right? And you have these concentric peaks and valleys. You have big mountains or little mountains. And when you're comparing, say, one effect to another effect, the effect actually operates on different scales. And so, in terms of y-axis scales, if that, what we need to do, long and short, is called range normalization. So we want to normalize the range of the scale. Okay? The reason for that is because if we don't do that, and we just compare the magnitudes of those ERP voltages, maybe we find a difference between them. But that's just saying that one mountain is bigger than the other. It doesn't say that the mountains are big. You know what I'm saying? So what we need to do is we need to put the mountains on the same scale. So you have Mount Dallas versus Mount Everest. We need to put them on the same scale. So basically normalize. So this is understanding of normalization. It's not average. It's kind of like disease function. Normalize. What's that?
It's hitting back right now.
Yeah. Yeah, I know the feeling. So, yeah, we want to put it on the same scale. So you don't have apples on scales.
Okay, so then how do we go about doing that?
Exactly what I'm going to get to.
Okay.
But I just showed you the math sheet. That explains why it mattered. You don't really learn that.
Okay.
Okay, so let's see what happens. So I'll give you guys a screenshot. I'll send this. The idea here, what we're going to be doing, so basically is organized such that it's kind of a horizontal spreadsheet. Okay, these are going to be first of all, what we need to do is extract the statistics for all 32 electrons. That's step one. Okay, remember our statistical measurement tool? So you open that. So we extracted the stats from one site, one electron. Because what we need to do is we need to normalize a set of electrons, like a frontal and a posterior electrons. We need to normalize them to the whole group of electrons, which means we need to know what the whole groups are. So what you can do is across the top here are electrodes. So you have like C1, P1, T1, F1, 2, yada 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 across. And then down here, there's actually subject numbers. So it's 1, 2, 3, 4, 5. This is just how the spreadsheet is organized. Okay. And all you're going to do is I've already made the spreadsheet as where I put all the formulas in the boxes. So it does all the math. It's just a calculation. All you do is when you get all those individual electrodes, you need to extract it all 32, and you end up pasting them in, ordered in this way, while your subject's down, on each row, or excuse me, column down, and then at the bottom, there is essentially your mean, your group, right? This is your group, and this is the action. That's what you want. You want the average numbers down here.
So once we have those averages.
Yeah. Then what you do is those averages are given to you then and are calculated for you as the range normalized.
Okay.
Averages, which is setting the apples to apples.
For each electrode for all the stuff.
Yeah, you'll do this basically once, because you'll have all the subjects out for each lecture, so. And it'll make more sense when I'll show you the Excel file too. I just, and that will give you your range normalized values. What you should do this for is the difference wave, so you don't have to do it twice for each condition, and you extract the stats. Remember, you select your bin, select the bin for the difference wave, which is the effect that we're trying to contrast. So that saves you one step of work. And you will do that for the difference wave of the condition that is old, let's say, and the you will do it between the difference wave, say, between explicit and implicit contrast. And so you'll do this once for the difference wave for implicit memory, for example, and then you would repeat this and do this process again in a different spreadsheet, just a different file you name. You paste in the different information for the implicit memory. And then you grab the electrodes of interest, whatever circle or patch you want, and you run the stats comparing it. That's the conceptual overview, and I'll show you the actual spreadsheet and calculation of how that happens. But before I go into that, I wanted to just visit about making sure we're on the same page of what we're doing and why. And then we'll get into the how. Does that sound good? Okay,
I have a question.
Yes.
So for our rough draft, how many are we allowed to edit?
Rough draft for what?
For experiment 2.
Who's due date?
Yeah, I know. But like, are we allowed to still work on it?
The rough draft is good. Rough draft should be good.
Rough drafts are due and they're optional, so should we like
The
get
rough
back
drafts
to-
were due before today, because today was, yeah, today was 2. Lab report 2 is due. Yeah.
Well, they need experiments, so that's not until.
Well, experiment 2 was supposed to be included in the second lab report. So that was due today.
So lab,
Half the class is
the
over.
second lab report draft,
Yeah.
right?
It
It
said
said rough draft is due today
where did it say rough draft?
on the syllabus.
Yeah. Okay. I said that.
Because I think half the class is under the impression that the rough draft is due today.
Okay. I mean, I'll go by whatever the syllabus says. I thought there was a regular draft, but if it says rough draft, that's fine too. I mean,
Yeah,
I'll
it
just,
does say rough draft.
I mean, it's just you can check out, figure it out. So yeah, if it says rough draft due today, then it's next week that the main draft is due.
And then if we are still working on our rough draft, is it okay to send it in like later today or something?
Yeah, I will talk to Ariel about
It's like to
that.
ask you.
Oh, I mean,
Wait, so, okay, I guess I'm confused then.
yeah.
So, the rough draft was due today.
Well, I mean, they're saying so. I need to look at the syllabus. It's just a question of does the syllabus say that?
Right.
If it does, then it, I mean,
Okay,
it is what
so,
it is.
right, so what I was telling you is that if there's something due today, I can't give you feedback on it.
Okay.
But if it's a rough draft and you have another iteration of it,
It's just a rough draft.
then yeah.
All right, we'll just make it says draft, so that's fine. So it won't be due today then. Yeah, real good. But next week,
Okay,
do that.
thank you.
Can you think you can make a short e-learning announcement first?
So what is due next week?
The
final for
the
experiment
final
2.
draft, right?
Yeah, not the final draft. The lab report 2
Oh,
is
okay.
due next
With
Friday.
experiment 1 and experiment 2.
Yeah.
Should include
With the
Yes.
results.
the results for experiment 1 should be the most part. We didn't do the results for experiment 1.
No, you definitely should have results for experiment 1.
Oh,
well then yes.
Yes.
By now it should be done.
So it should be experiment 2 and the results from experiment 1 and experiment 2.
And the discussion.
So I use experiment 2 with the physics is optional. That's what's free.
Experiment 2 is not optional. You need to have something added. You have to have something added to the first lab report, which is going to be the second experiment. whether or not, it's optional if you want to do experiment 2 on the faces.
Yes.
Okay.
You can do another set of hypotheses within the first data sets that you have in clinical patients.
That's right.
It's a really good point of clarification. So yeah, the second lab report, I recommend trying something different in a different data set, do something with the faces, you know, like, it's probably less boring, but, it doesn't have to be that set. I give that there as an option, but there has to be something else. And yeah, you guys are spot on, with all that. So now we're talking about like full tilt, results, discussion, all that for 2 experiments on your own. You know, get it done, write it up, ship it out, send it to me early if you want to turn it in early, get off your plate, and then dive into start. I would start immediately on that 3rd section with a group of people if you want, so that you can just start knocking out. Because just like everything, I think in this class, like it will probably take more time and work than you expect. Yeah. Usually when you add more cooks in the kitchen, it takes longer to do stuff than if you're just picking up your own sandwich. You know what I mean? In my estimation. Now there's like, oh, then there's this and there's that, and like, this go out, or yeah, now ultimately it should help to make things better. But if it takes a little longer, it'll take more stuff than you're expecting.
I think it depends on the strength
Of the what?
the strength of the cooks.
No, not necessarily. I mean, it just takes more time
Well,
for
that's
3 things to
right.
happen than it does for 1 thing to happen. Sometimes it's just 3 people reading and giving their opinions on what if they think it's fine. It takes more time for 3 people to read something each on their own and then come back and say, yeah, I think it's fine. And it does for 1. Like, that's just physical time, let alone actually doing any changes. Like, trust me, it can. It's good practice to get things done.
So today's step, we can send this back to the
Yeah, I mean, if you guys, you know, I was mistaken. I thought today was due. So apparently it's a draft. So yeah,
No, I thought it was two.
yeah. I mean, that's.
I'll just start with the experiment 2, but it's on the same data, it's just different.
Yeah. Thank you for helping me clarify that, because that's important to make sure we have there.
So as I make this announcement, to make sure all of my wording is precise, it's lab report with results for experiment 1, experiment 2, the discussion section.
Okay, including discussion of each experiment
Right.
results.
Okay. Is there anything else I should say? I mean, everybody knows that they have to have the other stuff as well, right?
Yeah, obviously, abstract, introduction, methods, results, discussion, conclusions, references, full lab report independently for 2 experiments or 2 sets of experimental hypotheses. I would note to people, obviously, the clarification, the reason this was sent out is because there was confusion about whether it was a draft due today or the actual report due today. I think I even emailed you last night with people saying the opposite to a couple of people who had asked,
Yeah,
because I was mistaken.
right, yeah.
But I would just clarify for them that actually I was mistaken about it, and that it's the draft due, parentheses, consistent with exactly as it's noted in the syllabus.
Okay.
I would have confused things even worse, but there's not confusing actually. I think this draft was supposed to be for the final report.
Did you add it?
Never been talking about like the times, yeah. So the idea of this draft was to get a couple weeks right, or yeah, we're gonna go back and review it so we had a chance to correct things.
I mean, yeah, we're just modifying, we're just adapting. Okay. You're right, it doesn't say anything for next week, but note that, that we, we're updating the syllabus so that next week, even though it doesn't say it's due, we're following up on the draft that was indicated in the syllabus as being due today.
Okay.
To clarify for everyone that the draft supposed to have been done out today is due in full form beyond draft form next week.
So final.
So people get stuck on the word final because it gets stuck into the final exam. I wouldn't use that term.
So I did get several emails from people.
I'll just write it. Don't worry.
Okay.
So in total, we're gonna have 3 actual due drafts or reports.
No, you have, you have 2 left. You have
So
next
the
week's
first one.
and the final.
So it's 3 total.
So we wrote 2 papers, right? There's 2 papers in the slides, so we have to write
So
them.
far?
No, we are going to. Because the first one didn't count, it was just a draft.
No, the first one counted, you get points.
Well, yeah, but it wasn't a full thing, we didn't have it right.
Yeah, but I called it a lab report. So,
So
and this is
then I
consistent with the syllabus as far as my memory is concerned, which is not always accurate, but as far as I remember things. What I said there was 4 components to your overall course grade, 4 components. You have, quizzes, what did I say, midterm?
Exam or 2 are anticipations.
Oh, did I say that 2 were not course? There we go, so that number's not always quizzes.
So, 2 lab reports, quizzes, midterms, and presentation.
But he gave us grades for the first one, so we should just.
That's what's common.
That is a good point.
What's it?
That, there's only 2 papers already.
No, I'm just reading. Yeah. That was a good point. I got confused between 2 different classes I teach.
Yeah, I remember the point of this draft to be that we had like 2 weeks to get ready for the final.
Oh, yeah.
It was supposed to be actually before.
Right, you're totally right. So yeah, do that. Hopefully you didn't send that out, right, Aaron? Yeah, I'll clarify. I'll send it.
Okay.
So,
So our the 2 papers that we're getting graded for, is that first one we did and the last one?
yeah, except the last one, we'll do it as a collaboration, so that we can do it as a group.
So are we still on 3 experiments?
3 experiments, right?
Yes, 3, absolutely 3.
Awesome.
For the final.
So the final one goes to
Just
huge.
It should be your focus.
Yeah.
Like Mr. Holland's office, it should be that for you.
I have a question while we're talking grade ones. You offer the screencast first or grade. There's also a seminar, workshops for, IRE protocols, and when you have problems with your collaborators. If you attend those sessions, that's the same.
Nah, I don't wanna give people more work to attend to other things, but,
I
yeah.
just don't think they'll let us in if we're not doing research, like if we're not PhD students. So
They'll probably let you. I wouldn't worry about that. Yeah, academics are pretty open to that type of thing. Especially something about research ethics where more people should be attending. They're not gonna kick people away. They're gonna welcome you in. So, you don't need to use extra credit as an excuse to go. I would just go and enjoy it, see if that would be interesting. So yeah, don't worry about that. But the screencast, yeah, if you want to do that.
And can it only be in screencast, can it be like, infographic or PowerPoint, like on, can it only be screencast?
I don't know what an infographic is. The screencast should be showing people, basically it's you teaching somebody how to do what you do.
But I think we're just gonna see like next week or 2 class.
It might.
So there's basically the stuff that we struggled with.
Yeah, I mean, I'll put it on the class's YouTube channel or whatever, and I mean, so who knows, people in Bangladesh will watch it or something. But again, that underscores the professionalism that's expected, like, to get extra credit, like, it needs to be done right, so that it's actually communicating in a useful way, something that somebody can actually use and not pull their hair out without, you know what I mean?
This is what they're, it's not, and I get this is their,
But area code for the first class, call them notes, like steps to follow to set up that lab. and
Yeah,
stuff.
I mean, that looks good, it's just, I don't know what you would do for a screencast of that.
oh no, this is just like a PDF, like a picture.
Oh.
But
I mean, if you have that stuff and you want to share it for other students to benefit from, that'd be great, but those are basically just notes, and what I was hoping to do is actually provide an auditory guided, you know, if somebody narrates and shows the screencast of what you're clicking on to do what, you know, teach somebody. If people can be helped. I think you guys would like if somebody did that for you, right? Last semester. So that's the idea with that project. Optional, but
I really like the collaboration thing because of that, because sometimes, like, you might have tons of questions like the policymakers, but also you might actually help a little bit, you don't even know you have some questions until you work with someone else.
Yeah. Let me see if I can get this spreadsheet up real quick.
Goodness.
So I have to run down
Okay.
to CBH. The talk for Monday, how long should it be?
Hour and 15. Just a class left lecture.
Okay, all right. And I'll probably be pretty interactive. Is that okay?
Yeah, totally. I mean,
Perfect.
it can go 45, 50 minutes if that's what you want to practice at level at for like a seminar, but
Do you
I
like
mean, the class
discussion?
itself is hour and 15, so expect discussion, so yeah, bump it down in time.
Cool. And how big is the class?
I mean, I had 6 people show up last class, but there's 20 in it.
Oh, wow. Okay.
Right.
I thought this was for a big group. But
No, it's a small memory class.
Okay, memory. All right.
Yeah, I should be there too, I think.
Okay. For some reason, I thought it was your, what was the other one? I think it's behavior neuroscience. Okay, cool.
Yeah, that's a different class. That's large.
Awesome. Thanks.
You're welcome.
Congrats on your paper.
Oh, thanks. Yeah, we're pretty pumped. Strength recording. Okay, so for those of you guys who are interested, okay, so I'll start first, just because I mentioned that for the implicit memory contrast. This is that basic idea here. Okay, you would paste in the trial numbers. Of course, it gives you your event code. This is the extracted from a script I would provide from MATLAB. And then we have the random number generator already here. And then this is our calculator. So once you paste all this whole basic array in, this will automatically count how many trial numbers there are in each of these bins. Now, granted, it's separated by 61 and 62 because we have those different encoding conditions. We want to make sure that we randomly select actually the same number from each task, just to make sure that that can't be used as an explanatory excuse of the data. So you want to randomly select, basically we take, to generate our old new thing, it counts the minimum number of trials in each of our bins based on this calculator, okay? Then we would need to select the minimum of each, So 63 is our new trials. That'll be the same number that we identify basically in our minimum. And then 61 to 62 is going to be basically half of each of these because it's divided by the two conditions. That gives you that. It tells you some steps to make along the way. Then you just grab one or the other. I mean, that's easy. Thanks. And so basically this is the basic thing. This will give you the numbers you need. Then you sort by the event codes. So your conditions are all the same. Then you just randomly, and you sort by event code. And secondly, you sort by the random number generator, which is why you just grab the first chunk that numbers that corresponds to what you need to accept. Accept, and reject everything beneath because it's already been randomly sorted. Once that's been done for every single one of these across, then you resort it so that it's back to 1, 2, 3, 4, 5, 6, 7, 8, 9 trial order. Then you can go through and do this. That's the implicit memory sheet. Here is the range normalization one that we just got done talking about. Okay? What we have here are our subject numbers, just like we said, 1 through however many. This is every single electrode. So you get that output for every electrode for the difference wave of your condition of interest. So let's say old minus new. Okay? And you basically paste it in. You'll see I have little boxes of instructions that guide you step by step. Step 1, step 2. Okay? So I've kind of tried to really like proof it so that it's tough to, not impossible to screw up. And then what that does is, let me take it, I'll zoom out real quick here. It's a massive spreadsheet, okay? And I've already done all the calculations for you for the most part. So all you do is basically paste those values into here. What it does is this is part of the calculation sheet. This is done. Now these are all sort of weird, goofy numbers because they're just, it's a calculation. So see if I grab one of these. See how here it tells you the calculation that's being done. So it's all going to think for you. All you do is you paste in those numbers up top, and when it does that, whoop, where am I thinking? What you're ultimately going to do is get, this is what you want. These are your final outputs. These are your average values for the entire group of that range normalized microvolt for that difference wave condition. Okay, so these are your suckers here that you would get there. That's the mean average, and because you would do statistics, right, that require using all the subjects, that's going to be this final bottom left section of the chart. Okay, so you grab whatever electrodes you want to create that cluster of, and you do that here. So this is the range normalized version. Okay, and really it's sort of a copy paste function. I've done all the math. You don't need to know about the math at this point, but that's it. You basically you normalize it to the range, the minimum and the maximum value. You work out the math, but that's already done for you. It's a big plus. If you want the sheet, email me personally for it. I don't want to post it on the site to confuse people who don't want to use it. You know what I mean? So I want to make sure that I give you the right sheet and that basically it's only accessible to people who understand what we talked about it so that they don't get overwhelmed or anything like that.
Would it be possible for you to do like some sort of demonstration, like a video or something, so because I feel like I would understand a little better if I could see it like in action.
Totally. And so that's maybe next. Shit, Bambi's coming next class.
Instructor Dolorosa demonstrating how to do an SLO.
Yeah. She'll do that, but I mean, there's a lot of class time. Maybe there will be some free. Maybe there will be some free time at the end of class. And maybe we can work together, and I'll make like a screencast walking through it for you guys on my computer. Yeah. So that's it. Email me if you want the spreadsheets for either implicit memory or for range normalization, because I need to make sure that, so some of these are like set up for like different experiments that I had 29 electrodes instead of 32, which changes the math. So like, just, I want to make sure I get you guys the right stuff. And it's going to take me a little bit just to sort out, make sure I give you the right files. That's it. Make sure you house the coffee and the food. Let's go. You already housed it. Okay.
So, sorry, just to clarify, you did two of these spreadsheets, right? You did one, you used the spreadsheet twice, right? You said you did one for implicit memory.
Yeah, so that's what you would do. Yeah, so this is what you would paste in, right? All the action that you're really doing is just a paste job here.
Yeah.
This is you would do for one of these difference waves. You'd get it, you'd paste it in, you'd save it as. Then you'd open up the original template again, which is going to be empty. You paste in that difference wave. It's going to give you a different result because it's a different set of data. Now you have down here, right? This is your output. That's why I highlighted it in yellow all the way around here, right? That's where all the magic happens. And you would grab, let's say, CP3 through CP or P7. You grab these guys. You could make an average of that if you needed to as a single cluster point, and you would run it. So, for example, let's say I would do cluster of 4 equals average of 1, 2, 3, 4. Average of that cluster, bam, there. Okay, so now you have a single basically electrode vector, like just like you're used to doing, right? You do stats on one line compared to one other line. So you do this for this condition. Then remember I said you need to open up another file and do it for the other contrast? You do the same thing, get this one. Now you have these two columns, which is right back to where we started about doing a basic t-test. And that's what you would do. Which I know it might sound complicated at first, it's actually really simple. But we can revisit it next class.
Okay.
And none of it's necessary. You don't even have to bother with a topographic analysis for your projects. Only if you're so inclined. Indeed. Yeah, because there's some really great hypotheses that can be made about it. Absolutely. I'm really pumped if you can do it. Cause,
Well, that's
what?
we want to do for our experiment.
Yeah. And so I'd be pumped if you could throw this stuff in. I'd be like, this is great. It's way more advanced than we were able to get last year. So, I mean, it's all gravy for me. I think it's really cool. So, but it's also not necessarily. So, anywho, like I said, I'll shut this stuff down, but email me if you want the files so that I can make sure I give you the proper ones. And if you're interested in the implicit memory thing, team up with people so you can, if you can get a large group, we can knock out this manual process for all 50 some odd people.
What if the whole class just turns in at once?
You know, if you do that for an oscillatory analysis so first of all, like I said, if the whole class contributes and does that oscillatory analysis for the implicit memory effect on all 50 or 60 some odd subjects, and we find reliable effects in the oscillatory domain, I mean, sheesh, I'll write it up with you. We'll publish it.
Can we just do like this side against that side?
Competition does breed improvement, right?
Write it up and publish it. That sounds like.
Yeah, I mean, but that's what I said a moment ago. Nobody's ever like I don't mean to like overscore the data, but it's an important point to note that, you know, this data is incredibly rare. It's incredibly sensitive to have physiological data of implicit memory of hippocampal amnesia patients. Nobody else in the world has this. It's never been taken before. I published one paper on it. but nothing else really exists yet because it was too hard to try. It's only 3 people. Who thinks you're ever going to find anything significant, right? Sample size issues. But we sorted that out, and we made it work because we tried. We tried hard, actually, and it became very fortunate. But I wasn't sort of being, what's the facetious or whatever. I wasn't just goofing off by saying nobody else in the world has ever found oscillates. They haven't. We don't know what the oscillatory correlates are of this hippocampal memory effect. And so if we really truly find something, like, hell yeah, we try to publish that. Hell yeah. I will absolutely be teaming up with you to do it. Like, we'll write that shit together. But we got to do the work.
Right.
And this is the most important part. It has to be done correctly. Think of all the steps that we just walked through today. Every single step, every single time I drew something on this board represents an opportunity for things to be totally screwed up. You're in the Army, right? What's a plan?
What do you mean?
What is a plan? It's just a list of shit that doesn't happen. Right? That's what my buddy said when he came back from Afghanistan. He's like, yeah, you have a plan before every mission, and he's like, it's just a bunch of stuff that doesn't happen every time you're on the mission. Right? I mean, every time that there's something to do with 1, 2, 3, 4, 5, 6, 7 people, it's an opportunity for one hand of one person to make a mistake about one box that's checked, multiplied by 7 people for every single one of the steps that has to happen. We need to be incredibly careful and cautious to do it properly. But if it is, and if we get cool findings, really any findings, significant, then that's, depending on what we find, there's a lot of factors along that road. But I'm really interested. Like, I'm going to be doing it in my own laboratory anyways. This exact thing. That's why I want to be so careful to getting the right files to you guys, because it's the same files I need to use for my lab. I'm really interested in what these results are, and if they're real, and if they're good, and if they're, like, we'll publish that, or we'll try to. Because, I mean, it's cool. So, yeah. That's my note to you, though, is that if you do that procedure, it must be foolproof. Like, no margaritas during coding this time around. Like, this has to be a very careful thing.
I sent you the averaged pictures.
Oh, did it work?
Yeah, apparently you can just import them in on Photoshop and it does it for you.
Hey, sweet.
You do it the right way.
That's pretty awesome. All right, I'll very excitedly take a look.
Okay.
So.
Enjoy your weekend and thank you for
Thanks, Val. You too.
Okay, Dante, could you upload the average picture? I'm just curious to see how it would look.
If I get it and it looks cool, yeah.
Yeah.
Yeah, totally. I mean, I want to see it too. I haven't seen it.
Yeah.
We're not doing mean amplitude for the topographical analysis, right? It was what?
Well, the value is mean amplitude. Yeah, it just becomes a range normalized mean amplitude.
Okay.
So you need to let all of your work is
How did you go down this kind of research path? What drove
Accident.
Really? What drove
So-
you to be involved in
Serendipity, man.
that lab and
Oh, dude. They say necessity is the mother of invention sometimes. I mean, partially I thought it was interesting and cool, and you have the vision of what you see the future, like of the field moving towards as well, and where you think is going to be an important avenue for research or what you're interested in. But that only, that goes hand in hand with sort of like good luck and things working out and sort of serendipitously bumping into the right people who, you know, taught me MATLAB and showed me why it's important and showed me oscillation. I mean, you know, like that was serendipitous. Like the pre-stimulus theta thing, where I said a couple other guys joined the lab and did a rotation and did that analysis, and it's like, holy sheesh, there's all this cool stuff. I mean, a little bit of both, right? It's kind of like the overarching storyline philosophically in Forrest Gump is, you know, that's why they have the floating feather throughout the movie, is this all just one random crazy world, or is there like a higher power of like intelligent design, so to speak? Like, is this just a random feather flopping around just going wherever, or is it, you know, is there sort of a guiding, and do we play a role, you know, in that? And it's right, I mean, a little bit of both. Like, there's some random serendipity of like, I just happen to have been fortunate enough to bump into people who taught some of this stuff to me and cued me into it, and other aspects of it I knew I wanted to go towards.
Did you know you wanted to teach?
Yeah. You know, at first, really, what I wanted to teach was high school wrestling. I mean, that's what I came from. That's what I thought I would do. And pretty early in college, like as an 18 or 19-year-old, I kind of realized, like, you know, teaching's cool, but it sure would be nice to pick my own hours to teach rather than having to show up at 7 in the morning every day and be a hall monitor and babysit a bunch of high school kids. I'd be pretty nice to set your own hours of when you what block of time you want to teach, like they do in college. So as an 18 or 19-year-old, that's sort of like really base level thing was like pretty important to me. I'm like, I like sleeping in, right? Of course, as you get older, you like those things matter less and less. But that at that age kind of helped shift me towards like, well, if I'm going to teach, maybe I should teach in college, because maybe it allows me to be with my kids a little bit more. I can get them on the bus in the morning rather than me having to be at school at 7 in the morning. You know, so, you know, being 18 and 19, wanting to sleep in a little bit more, I was like, oh yeah, well, I'll try to teach in college instead of high school. Oh, well, what do I have to do? Oh, I got to go to grad school and get a PhD. All right, I guess I'll do that. How do I do that? Well, what do I got to do? You know, and you just. But yeah, so I always like teaching in that regard. But
you ever tried to join the military? You always related to asking topic.
Yeah,
you got a lot of friends in it.
Yeah, I have. I've thought about it for quite some time. I tried once or twice. I went to MEPS a few years ago, actually.